We're going to take exactly what we've been doing, and we're going to just relate it to the concept of probability. Okay, and the concept of probability means the chance of something happening. Okay, so probability is the chance of something happening. And we represent probability as the number of favorable outcomes out of the total number of outcomes possible. Okay, so we're going to take the number of times that thing, whatever you're talking about, happens over the total number of times it could happen. Anything could happen. Okay, so for example, if I said roll a die, what's the probability of getting a 1, 2, or 3? Three times that you could get a 1, 2, or 3. 3 different ways you can get a 1, 2, or 3. You could get a 1, you could get a 2, or you could get a 3 out of 6 numbers on the die. So it would be 1/2. We do always reduce the probability. You could write it as 1/2, you could write it as 0.5, you could write it as 50%, all meaning the same thing. Okay, based on a survey, the number of text messages that teens send and receive every day is normally distributed the mean of 100 and the standard deviation 25. This is the same problem we keep using. Okay, so I made the little normal curve for you. You randomly select a teen from the survey. Calculate each probability. Determine the probability that a randomly selected teen sends and receives between 100 and 125 text messages a day. So we're talking about this area. It would be 34. Good. Okay, that's the empirical rule. Okay, you're just memorizing that, nothing special. Determine the probability that they send and receive fewer than 75 text messages a day. Okay, so now we're doing this whole piece. 16, how are we getting 16 again?
It's from 75 to 50, that's 13, and from 50 to 25, 50 down is 2.5.
So 13.5 and 2.5 would be 16. So good. You could do 13.5 plus 2.5 and get 16. Could you do it any other way? You could do 50 from 100 down minus the 34 that you don't want. Okay, so or 50% minus 34. However you see it is fine. Either way, it's 16%. Questions? So what we've been doing all along is probability. We're just really calling it now. We're calling it that now. Okay, determine the probability that a randomly selected teen sends and receives more than 140 text messages a day. Okay, is 140 an exact standard deviation away? No, so we have to do the z-score. So we're going to find the z-score first. Z equals 140 minus the mean, which is 100, divided by the standard deviation of 25. So that gives you 1.6. What does this mean again in words? Good. That means 140 is 1.6 standard deviations away from the mean, above the mean. Okay, we're going to look it up in the chart. So look up 1.60. Okay, look up in chart, and you get 0.9452 or 94.52%. Is that the answer?
No.
Why not?
Because we have to determine the probability that the randomly selected teen receives more than 140 text messages per day.
Okay, what does this represent? Yeah.
Less than 140.
Okay, this represents less than 140. Okay, so we have to take 100 minus 94.52%, and we'll get 5.48%. This number you look up in the chart always represents less than. Always. Okay, so anytime you have a more than problem, you're going to have to subtract from 100 at the end. Questions? Okay. You have collected data on delivery times for 2 local pizza shops, Antonio's Pizza and Wood Fire Pizza. Based on your data, Antonio's Pizza has a mean delivery time of 30 minutes and standard deviation of 3 minutes. Wood-fired pizza has a mean delivery time of 25 minutes and a standard deviation of 8 minutes. A friend of yours is planning a party and she needs a pizza for the party delivered in 35 minutes or less, or the party will be a complete disaster. Which pizza shop has a greater probability of delivering the pizza within 35 minutes? Okay, so we need to do the z-scores for both of these. So z for Antonio's, not Anthony's. Antonio's. Okay, it is 35 minus the mean of 30 divided by the standard deviation of 3. So that's going to give you 1.67. Okay, look it up on the chart. .67 gives you what percent? Good, 95.25, which means 95.25% of the time, Antonio's okay, Antonio's will deliver within 35 minutes. So in 35 minutes or less. Okay, why don't you guys do the same thing for the wood fire pizza?
You guys got negative 1.6. What? Negative 1.6.
Okay, I think some of you are using the 30 and the 3, but that's not for wood fire pizza. So 35 minutes minus their mean, which is 25, divided by 8. Otherwise, you're going to get the same answer.
Oh, worse.
Okay? So you had to use their mean and their standard deviation and get 1.25. Are we okay? Okay, so then when I look up 1.25, then it says 89.44% of the time it will be delivered within 35 minutes. So, if it's important to this person that's throwing the party to have it delivered within 35 minutes, which company should she go with? Antonio's, because she has a bigger probability or a better chance of it getting delivered within 35 minutes. Okay, based on past data that they have shown. Questions? Okay, Brad and Toby both plan to enter a county tomato growing competition. Each person who enters the competition must submit a basket of tomatoes. The judge randomly selects a tomato from the contestant's basket. According to the rules of the competition, a gold tomato has a diameter between 4 and 4.5 inches. Okay, the diameters of the tomatoes in Brad's basket are normally distributed the mean of 3.6 and standard deviation of 1. The diameters of the tomatoes in Toby's basket are also normally distributed. The mean is 3.8 and the standard deviation is 3. When the judge randomly selects a tomato from both baskets, who is more likely to result in getting the golden tomato? Okay, so we have to do z-scores for both, but we actually need it between 4 and 4.5, so we need to do 2 z-scores for both. Okay, so for Brad, I'm going to do the z-score for 4.5, so 4.5 minus his mean, which was 3.6, divided by 1. And that would give you 0.9. And then I'm going to do the z-score 4 minus 3.6 divided by 1. And that gives you 0.4. Okay, so we need to look those up on our chart. 0.90 and 0.40. What does the 0.90 give you? 81.59%. What does the 0.40 give you? Good, we're looking it up correctly. Okay, and if we want something between those two, what do I have to do? Subtract them. So when I subtract, I get 16.05%. Okay, so 16.05% of the time, when they pick up tomato from Brad's basket, it will be between 4 and 4.5, or a golden tomato. Okay, we have to do the same thing for Toby's basket. So we have z equals 4.5 minus his mean. What was the mean in Toby's basket? 3.8 divided by 0.3. You guys can help me with that one. What does it give you? And you got to round to the hundredths. 2.33. Sounds right. Okay, z equals 4 minus 3.8 divided by 0.3. So we're doing the z-score for 4.5 and the z-score for 4, because we want in between those two. Round it 0.67. Okay. Look up the percents. I think you get 99.01 here and 74.86 here. Is that right? Okay, subtract, and you would get 24.15% of the time his tomato would be between 4 and 4.5, or a golden tomato. So who has the higher probability? Who's more likely to result in the golden tomato? Brad. Or Toby, right? Because this one's higher. Okay, so
Does higher mean more probability, or does lower mean like you're closer to?
this means 24% of the time when his tomato gets chosen, it will be a golden tomato.
Oh.
This means 16% of the time his would be. Okay, good question. So Toby has a higher probability of having a golden tomato. Questions? So nothing's really new, it's just called probability now. Okay?